Hello, friends. Today I have one of those devices that you really want to place between the wall outlet and your appliance in almost every home, especially if your power grid likes to surprise you. Sometimes the voltage drops, sometimes it spikes, and sometimes you simply have no idea how much power your heater, boiler, or charger is actually consuming. This is the Atorch S1W WiFi Smart Socket. It is a Wi-Fi socket with a large informative display and built-in power consumption monitoring. It shows voltage and current, calculates power factor, and accumulated energy in kilowatt-hours, and even converts that into money right away. In other words, you are not guessing by feel, you are seeing real numbers. On top of that, it has protection functions that can disconnect the load if there are grid problems or an overload. So this is not just about remotely turning a lamp on and off. It is also an element of electrical safety and control. It works in the Tuya ecosystem. It connects through regular 2.4 GHz Wi-Fi, and you do not need anything extra besides a router and internet access. In this review, we will go through it in detail. We will look at what the display can do, what modes and settings it has, how it behaves in Tuya, what automations can be built with it, and separately we will see what can be done with it in Home Assistant. Model S1W. Power supply from 85 to 265 volts. Maximum load up to 16 amps or 3600 watts with a built-in 16 amp relay. Measurements include voltage, current, power, frequency, power factor PF, and accumulated energy in kilowatt-hours. Measurement accuracy is plus or minus 1%. The display is a 2.4-inch TFT LCD with a resolution of 240 by 320. Wi-Fi works only on 2.4 GHz. 5 GHz is not supported. Standby power consumption is up to 0.3 watts. Energy range is up to 1999 kilowatt-hours. Operating temperature is from -10 to +60 degrees Celsius. Dimensions are 133 by 76 by 73 millimeters, and the weight is 160 grams. The plug in my case is European, but the seller offers different options for different countries and standards. The socket comes in a very simple cardboard box. Nothing premium, but everything is to the point. On top there is usually a sticker with the product name and manufacturer information. On the front there is another sticker showing the selected plug type, in my case the European version, and there is also a QR code for downloading the mobile app. Inside, everything is minimalistic. You get the socket itself and the instruction manual. The manual is in English and Chinese, and what is nice is that it is not just there for show. The functions are described in enough detail, so it is actually possible to figure things out even without watching a video. In terms of shape, this is the familiar plug adapter style socket, but two things immediately stand out here: the large color display and the physical control buttons. And that is a real strong point of this device. Many parameters can be configured directly on the socket itself: voltage limits, current limits, power limits, relay operating modes, and timers. That means even if the internet goes down or your phone is not nearby, you can still set up basic protection and control and leave it working autonomously. Grounding is present, and there are child protection shutters as well. On the back there is a sticker with the specifications and the Wi-Fi marking. Personally, I have not seen Zigbee versions of sockets like this, but here at least everything is clear. This one connects over Wi-Fi. One more point. There is a warranty seal on the body. It is a small detail, but still nice to see. It makes the device feel less like a disposable product. When powered on, the socket goes through a short startup sequence, and on first launch it offers basic setup. I skipped that step and left everything at default. Right now I will show you what settings are available and what can be done with them. Let us look at the controls and at how information is shown on the display. Switching between screens is done by pressing the plus or minus buttons, and the information cycles through the available displays. By default, we see the screen that I would call settings and billing. In the upper part, it is labeled something close to that. In the same top line, we also see the relay status. A red open icon and the word OFF mean the relay is off. If we hold the plus or minus button, we turn the relay on or off. In other words, we simply change its status. At that moment the image changes, the icon turns green, and the word changes to on. This top line is present on all displays except the standby mode. Now let us look at the left side of the display. Here we see the current mains voltage, the load current in amps, below that the power of the connected device, the number of kilowatt-hours used, the grid frequency, and PF. So what is PF? PF stands for power factor. It shows what part of the power is actually useful active power and what part is reactive power that moves back and forth in the network because of power supplies, motors, and so on. That is why sometimes it seems like voltage multiplied by current should give a certain number of watts, but the screen shows less. That is normal, and PF explains why. In the right column, we are shown the price per kilowatt hour that we have set, and below that the total cost of consumed electricity. At the bottom of the display, and this is also present on all screens, we see the operating time, Wi-Fi connection status, an icon showing whether the buzzer is enabled, and the current temperature of the processor inside our socket. After connecting to the internet, the current date, time, and day of the week will be displayed there. To set the price of 1 kilowatt-hour on this screen, we need to press the M button once. Then we use the plus or minus buttons to adjust the values. Moving between positions is done by pressing the M button. For example, I set the value to 5, and right away the total amount changed. But that is not all. In the pricing settings, you can also define a second option called Price B. This is a billing option that depends on the amount of electricity consumed. In other words, instead of Price A, we now see 3 parameters. For example, from 0 to 100 kilowatt-hours one price, from 100 to 200 another, and above 200 a third one. The limits and prices can also be adjusted with the M button and changed with the plus and minus buttons. And after connecting to Wi-Fi, Price C becomes available as well. Here we can choose 4 different time-based parameters, so it becomes a multi-zone meter. These settings are useful if your electricity cost depends on the time of day, for example if you have a night tariff or even a multi-tariff system. If you only have a night tariff, then you assign the night price to one period, the daytime price to the others, and configure the duration of each period. It is a convenient way to monitor your electricity expenses more realistically. The next screen and settings are Smart Power OFFA. On the left side, we see exactly the same information as on the previous screen, but the parameters on the right are different. I would say that on almost all screens, the information on the left stays the same, so from here on we focus more on the right side, on the settings and functions. In this mode, we can set the power threshold for the connected load and a time value. For example, I set a threshold of no more than 100 watts and a time of 10 minutes. That means if, for example, a pump was running and then finished, and the load drops below 100 watts and stays there for 10 minutes, the relay will turn it off. Here you need to activate the scenario with the plus or minus buttons by switching the relay to the new auto status. After that, a countdown starts under the cutoff field for switching the relay off. To repeat it in simpler words, Smart Power OFF means that if the power drops below the set value and stays there for the set amount of time, the power will be disconnected. For example, you can set 15 watts and 15 minutes, and then the socket will disconnect a charger once it has effectively finished charging. On this screen, we can either switch power to auto mode so the scenario becomes active, or turn it on and off manually. The third mode is Smart Power OFFB. It is similar to the previous one, but the difference is that here we specify that the connected power must be higher than, for example, 500 watts. The time setting is different though. Here the minimum is 1 hour. In other words, if a device, let us say, goes crazy and starts consuming too much power, then after 1 hour the relay will disconnect it. What I mean is that making the time step only in hours was probably not the best decision. I think up to 99 minutes would have been much more practical. Again, do not forget to switch the relay into auto mode. The next mode is timing cutoff, or simply a timer until the relay turns off. We set, for example, 10 minutes, make sure the relay is switched to auto, and it turns on. Then on the C-down indicator we can see how much time is left before the relay turns off. After 10 minutes, the relay switches off, and you can switch it back to automatic mode again, and it will run for another 10 minutes using the same settings if you do not change them. Timing cut on is basically the same thing, except that here the relay is off while in auto mode, and after the set time it turns on. In other words, it stays off for the specified amount of time and then turns on automatically. The timing cycle mode is something I personally use for exhaust fans. It is a cycle showing how long the connected load stays on, then how long it stays off, and so on. For example, For ventilation you might have it running for 10 minutes and then staying off for 50 minutes. For demonstration, I set both intervals to 1 minute, switched the relay to automatic mode, and you can clearly see the countdown either to on time or to OFF time. The next one is already our 7th mode, timing countdown. It is somewhat similar to the previous one, but it is more of a delayed operation timer. In the CD on parameter, we specify the time after which the load will turn on, and in CD off we specify how long later it will turn off. You might say it would be more convenient to have this based on time of day. For that, we will need the app, but do not worry, we will get to that. This mode is more focused on autonomous relay operation without a phone. Then there is the mode related to display sleep and standby. In fact, it can be configured. To do that, we press M and can choose either to show large digits, like I have now, or to turn the display off completely. But one thing I noticed is that even when I choose large digits, the display still turns off after some time. I do not know whether that is just how mine behaves or whether it is intended to force the display off, but I am showing it exactly as it is. And the last one, although it would probably make more sense to start with it, is the connected load protection mode. Here we see that the numbers on the left have become larger, and there are now 3 main fields: mains voltage, current, and the power of the connected device. Here we can set the parameters at which the relay will disconnect the load, the upper voltage limit, in my case 275 volts, the maximum current, adjustable down to hundredths, the maximum power, which can be set even higher than what the current limit would suggest, and also the lower voltage limit, which is 75 volts by default. In general, if we do not want to limit the connected load by current or power, we can simply set those values deliberately high, for example 20 amps and 6 kilowatts, and leave only voltage protection active. That depends entirely on your goals and how you plan to use it. For example, I set 195 volts as the maximum voltage, and the device immediately trips and disconnects the load. Or, if the load was not turned on, it will not let you switch the relay on. At the same time, the display clearly shows what is happening. The current voltage is higher than the value I set. We press M, go into the settings mode, set a more reasonable maximum, for example 275 volts, and after that we can turn the relay on and everything works normally again. Then, for example, let us limit it by current. I set 6 amps and turn on a hair dryer. The protection trips, the relay switches off, and the load is disconnected. The same goes for power. I set 1 kilowatt, leave the current at 20 amps, turn on the hair dryer, and exactly the same thing happens. And if we do nothing for a few seconds, the socket goes into standby mode, where it shows large digits on the display, the current voltage, current, power of the connected load, and the total energy consumption in kilowatt-hours. But if you want, this can be changed, and the display can simply be turned off. To do that, we go into the settings. That is it, the display is now off. Let us now go into the settings. To do that, hold the M button for about 3 seconds. The first item is language selection. There are only 2 options here, English or Chinese. Next is display brightness. It can be set from 1 to 9. The following item is display brightness in standby mode, and by default it is set to 3. Then comes the time before the socket goes into standby mode, from 3 to 60 seconds. You can also turn the system sounds, meaning the buzzer, on or off. By default, they are enabled. We have already looked at the electricity billing display modes, and by default price A is selected. Then there are some interesting items related to calibration. Voltage calibration is available. If you have a reliable tester, you can calibrate the readings either up or down. The current can be calibrated in the same way, and separately the power as well. Yes, that sounds a bit strange because power is basically calculated from current and voltage, but since the option is there, it means you can fine-tune the readings if your reference instruments are more accurate. Next come the settings for maximum voltage, maximum current, and maximum power. These values are linked to what we configured on the protection screen. If you change the parameters there, they also change here, and vice versa. And here is a setting that I am seeing for the first time, and it is genuinely useful. It is the mode setting, which in practice determines how the relay works. If you choose the option where the relay is always on, then the load will be disconnected only by the protection functions, by maximum or minimum voltage, by maximum current, or by power. All the timers, cycles, and other modes will no longer be able to turn the relay off. This is convenient if you temporarily use the socket for other purposes and do not want to reset or accidentally trigger timers. If it is inconvenient that the socket stands vertically and the screen is upside down, you can rotate the display by 180 degrees. In standby mode, the main load and voltage values are shown by default. Then there is an important setting. If protection has tripped, by default the power is restored after 3 minutes if the parameters return to normal. This interval can be changed from about 1 to 99 minutes. That is useful so the socket does not keep clicking on and off when the grid is unstable. We can also set the relay behavior after a power outage. By default, it remembers the last state, whether it was on or off. But you can change it to forced on or forced off if that suits your needs better. There is also a setting that enables the startup check and splash screen each time the socket powers on. I disabled it on mine. Next, you can reset the kilowatt-hour counter, which is convenient to do once a month or for any other reporting period. There is also a separate reset for the Wi-Fi settings, and a separate full factory reset for the entire device. You cannot set the time manually without Wi-Fi because it is synchronized through the internet. However, there is a setting where you can define the delay before protection triggers for voltage, current, or power, and you can even turn this function on or off entirely. This is useful if your grid sometimes has short spikes and you do not want the socket cutting the load off because of every brief fluctuation. The second to last item is low voltage protection, and after that comes exit from the menu. You can leave the menu the same way by holding the M button. Now let us connect the device to the Tuya smart ecosystem. To do that, I will first reset the Wi-Fi settings in the socket menu and then open the Tuya app. I press Add Device and wait. You may be asked to choose your Wi-Fi network and enter its password. And within just a few seconds, the device is found and added to the smart home ecosystem. On the main screen of the app, we only see the relay status, on or off, but we can also change its status right there. The available functions are turn on, turn off, or auto mode, so you can control it without even going inside the device page. But of course, we will go inside. And now we are on the home page of the device. What can I say? This is the most detailed and informative page for load and electricity monitoring that I have seen. Here we see the relay status, the consumed kilowatt hours, the cost right away, the current voltage, current and power of the connected load. Below that we see the mains frequency, the PF value, meaning power factor, and the processor temperature of the device. These values can update almost in real time if needed. We simply enable that in the real-time data refresh menu. Below that is the relay interface selection menu, the same 8 interfaces we looked at earlier. We swipe down, and here we get a graph, hourly, showing voltage, current, and load. Below that is a graph showing consumption statistics in kilowatt hours. And even lower are the interface settings. We select Security Protect, and the interface on the device itself changes immediately. But we cannot change any values here directly. Why? Because you have to go into the settings and set the maximum and minimum voltage values there, as well as the maximum current and load. It is a bit inconvenient, but that is how it works. Now let us select the billing interface. If price A is selected in the settings, then we can set the price of 1 kilowatt hour. If we choose price B, then it still has to be configured directly on the device, it cannot be fully set from the app. Strange logic. Not very convenient. In the initial setup, you are basically only setting the price for 1 kilowatt hour anyway. Let us choose price C. It is more or less the same story. The time period parameters also have to be configured on the device itself. Not the most convenient approach. The app could definitely be improved in that respect. Now we move to the Smart Power OFFA interface. Here the power and time settings are available right away, just like we did using the buttons on the device itself. In Smart Power OFFB, I was hoping for a miracle, that maybe the hours could be changed to minutes, but no. The minimum is still 1 hour, so the condition for the programmed maximum power can only be held with a minimum interval of 1 hour. Timing cut OFF is the same idea, turning off after a set period of time. Timing open time means turning on after a certain amount of time. And the cycle mode is the same concept as before, on for 10 minutes, off for 40 minutes, and so on in a loop. Below that we see a trigger log showing when the connected load was turned on and when it was turned off. And at the very bottom there are 3 large buttons, turn on, turn off, or switch to automatic mode. Between them there are icons. The first one is for creating a schedule, which is empty by default, and the second one starts a countdown after which the relay changes its state. Now let us go to the graphs menu. The first graph shows the voltage in your main supply over the day, month, or year. Below that is the current graph, also shown by day, month, or year. Below that is the power graph, again by day, month, and year. There is even a graph for the processor temperature of the device. The last two graphs are related to kilowatt-hours of consumed energy. The first shows total consumption, and the second converts that into money based on the price per kilowatt-hour that you set. There is nothing really new in the settings menu. It is basically the same as what we could do directly in the device menu. Only a few items, such as reset and screen rotation, are separated out and turned into standalone buttons. At the time this review was made, there were no firmware updates available. The main module version was 1.0.0 and the microcontroller version was 1.0.8. Now let us see what this socket can do in terms of automations in Tuya. The structure here is standard. There is an if trigger, meaning some event or condition, and there is a then action, meaning what the system should do in response. For example, if something happens on our smart socket or some parameter goes beyond a limit, then the automation can turn another smart device on or off. We go into automations, choose create scenario, and in the if block we select our device. And here a really huge list of conditions appears. Honestly, this is the first time I have seen this many. But if we talk about what is actually useful, there are maybe 4 or 5 really practical ones. The first one is the current relay state, on or off. Next comes the current itself. Here you can choose conditions such as less than, equal to, greater than, inside a range, or outside a range. The same applies to connected power. Exactly the same way, you can build automations based on voltage, with the same condition options. And if you want, you can even tie automation to cost, for example disconnecting a load if the calculated electricity cost exceeds a certain threshold. I will just show the rest of the conditions because there are a lot of them. Theoretically, you can build automations based on them, but in most cases those will be very specific use cases. One practical idea would be, for example, to make an automation like this: if the mains voltage rises above 240 volts, then turn off other devices. But it is important to understand one thing here. This only makes sense if those other devices are actually on the same phase. Otherwise, there is not much point in such an automation. Now let us look at the second option, when the device is used in the then block, meaning as an action. For example, sunrise, then. We select our device, and here we also see quite a large list of things that can be changed. But the main thing, in my opinion, is still relay control, namely turning it on or off, which means controlling the connected load. But you can also create more interesting automations. For example, a time-based automation that resets the consumed kilowatt-hour values at the end of every month, or one that lowers the display brightness at night so it does not glow. Now let us see what our device can do in the Home Assistant smart home ecosystem. To do that, we go to Settings, then Devices and Services. Here we look for the Tuya integration or Tuya local, depending on what you use. We go into it and refresh the list of devices. We find our device, Atorch Smart Socket S1W, and open it. In terms of controls, there is only one function here, which is expected, turning the relay in the socket on or off, and therefore controlling the connected load. Below that, in the Sensors section, we can find 3 inactive parameters, namely current, power, and mains voltage. But by default they are disabled. We choose any one of these sensors, go inside, click the gear icon and make it active. I enable all the sensors and wait about a minute for the information to update. And after a short while, we can already see the current, power, and voltage values. Statistics will also be collected based on these values, which is convenient for control, monitoring, and further analysis. In the Activity section, you can view the log of when the socket was turned on and off. And if needed, both the socket control itself and the sensors can be added to the Home Assistant dashboard so everything is visible in one place. In the end, This socket left a very good impression on me. At first glance, it looks like just a smart socket with a screen, but in reality it offers much more practical value. It not only turns the load on and off, but also lets you see voltage, current, power, energy consumption in kilowatt-hours, and even an approximate electricity cost in real time. On top of that, it has genuinely useful protection for voltage, current, and power, several autonomous operating modes, timers, cycles, control through Tuya, automations, and integration with Home Assistant. Yes, the app is not perfect in some places, and some settings are more convenient to make directly on the device, but considering the overall functionality, that no longer feels critical. In essence, this is a good tool not only for a smart home, but also simply for everyday control of household appliances. It helps you understand how much power a device actually consumes, protect it from grid problems, automate its operation, and get all of that in one device. So if you need not just a smart socket, but a genuinely functional device with monitoring, protection, and a solid number of settings, then this is a very interesting option and, in my opinion, definitely worth your attention. All links to the products shown in this review are in the description below the video. There you will also find a link to my Telegram channel, where you can find new gadgets, discounts, useful tips, and live discussion. There is also a forum dedicated to smart home systems, and now everything is neatly sorted into sections, so finding the topic you need has become much easier. Do not forget about our Facebook group and our page on X, formerly Twitter. I post fresh news and useful selections there as well. If this video was helpful, leave a like, subscribe to the channel, and press the bell so you do not miss new reviews. Thank you for watching, peaceful skies and all the best. Bye bye.